The most important property of squares and square root is property number 6, Pythagorean triplet. If you haven't seen my previous video where I have discussed about remaining 5 properties, you can click on the I button which is flashing on the top right side of your screen. Pythagorean triplet says if A, B, C are three numbers where C is greater than both A and B also, the sum of the squares of other two numbers is equal to the square of third number, then A, B, C are called members of Pythagorean triplet. This Pythagorean triplet is derived from Pythagoras theorem, which is entirely based on right angle triangle. So let's quickly discuss the basics of Pythagoras theorem. It is based on right angle triangle where we have 90 degree. One of the side which is the largest is known as hypotenuse here, which is C. H is known as height, or you can say perpendicular, and the third side is known as base. So if I'll compare with ABC, so perpendicular height can be A and base can be B. If you observe these three members of Pythagorean triplet, 2m is the only member which is free from exponent, hence 2m is the smallest out of all. Now coming to remaining two members of Pythagorean triplet, both members have m square in common, but in one of the member one is subtracted, in other one is added, which clearly means where one is being added is the largest one. Now if you take the example where 2m is equal to 14, with the help of this information you can easily find out the value of other two member. After solving this equation, m is equal to 7. Now if m is 7, m square minus 1 will give you 7 square minus 1, 49 minus 1, which is equal to 48. And m square plus 1 will give you 7 square plus 1, which is equal to 49 plus 1, that is 50, which means 40, 48 and 50 are the Pythagorean triplets. The only disadvantage of this Pythagorean triplet, or you can say the only restriction, is that we can apply this property only when 2m or the smallest member of Pythagorean triplet is even. If it is odd, then we cannot apply this Pythagorean triplet property. Can we apply Pythagorean triplet here in this question where numbers are given 5, 12 and 13? According to Pythagorean triplet, we have these three members 2m, m square minus 1 and m square plus 1, where 2m is the smallest member, and according to Pythagorean triplet, the smallest number should be even. Then only we can apply Pythagorean triplet. If you look at this example, 5 is the smallest one here, but unfortunately 5 is odd number. So we cannot apply this Pythagorean triplet property in this particular question. But how to check whether these numbers are Pythagorean triplet or not? So what we will do here, we will apply Pythagoras theorem, which says a square plus b square is equal to c square, where c is the largest number. In this, 13 is the largest one. A square you can take 5 or 12, it's up to you. 5 square plus 12 square. So 5 square is 25, 12 square is 144, 13 square is 169. 25 plus 144 gives you 169, which is equal to 13 square, which is c square. Hence, using Pythagoras theorem, we can say 5, 12 and 13 is a Pythagorean triplet.